that consider the two relations R1 A comma B with the tuples 1 comma 5, 3 comma 7 and R2 A comma C which has the tuples 1 comma 7 and 4 comma 9. Assume that R ABC is the full natural outer join of R1 and R2. Consider the following tuples of the form A comma B comma C, and you are given here A, B, C, D, E, F and G with their respective values. Okay, so which one of the following statements is correct? Now at the first glance this question may look a little difficult to you, but let's start drawing the relations that are specified. So here we are given two relations R1 and R2. So R1 has two columns A and B. Alright, and the values of these two columns are 1 comma 5 and 3 comma 7. So 1 and 5 is one tuple and 3 comma 7 is another tuple. Alright, so this is one relation R1. Now we have another relation R2, and R2 also has two columns, but the columns are A and C. Okay, so the common column in both these relations R1 and R2 is A. Alright, and the values that are present in the tuples of R2 is 1 comma 7 and 4 comma 9. Alright, now we are provided that R is the full natural outer join of R1 and R2. Alright, so here you need to know the concept of full natural outer join. So a natural join, what it is? Natural join basically takes two or more relations. Here in this case we have two relation R1 and R2, and it combines the tuples of both these relations based on the common column. In our case the common column is A. Okay, and what is outer join? Outer join basically ensures that if the values for the value of the common column is present in one relation and it is not correspondingly present in the second relation, then we substitute the value null as the value of the columns of the second relation. So what do I exactly mean here? I'll explain it to you and then I'll write the answer that will be forming the full natural outer join. Okay, so in this case, as I said, the common column is A. Now what we have to do to obtain the full natural outer join? We pick these, we choose any of the relation and we start picking up the tuples in it. So I start with R1 and I pick this relation 1 comma 5. Okay, and I start forming the outer join, which is the full natural outer join, which will have all the columns A, B and C, and the common column will be present only once. It will not be repeated. Okay, so I start with R1. The first tuple is 1 comma 5. Now since the value of the common column A here is 1, I look for 1 in the second relation R2. Here also the value of A is 1 in this particular row. Alright, so what do? I pick up 1 from here, I place it in A, I pick the value corresponding to 1 and in the column B from R1 and I place here, which is 5. Then corresponding to C, the value is 7 in R2 and it is also present along with A as 1. So I place it next to these values that I have already written. So what you actually do, you pick a value of the common column and write down all the remaining values in that row present in relation 1. Then you see if this value is present in the second relation also. If it is present, then you write down the values of all the other columns. Here the other columns is C and you write down these values along with the values that you have written from relation 1. Alright, so we'll continue this. We'll pick the next value from R1. The next row is 3 comma 7. I place 3 here. Then I place 7 here in the B column. And then I see is 3 present as A's value in R2? No, 3 is not present as A's value. So what do? I substitute the value of C as null. Alright. Now since all the rows of R1 are done, I start with all the rows of R2. Since we have already covered this row 1, 7, so I go to the second row. The second row says that the value of A is 4. Okay, so I make another row here in the full outer natural join and I put 4 here. Then the corresponding value of C is 9. So I place 9 here, and just like we did in the previous case, for the value 4, I look in relation R1. Is there a value of 4 that is present here? No, there is no such value. So in the columns that are present in R1 but not in R2, I substitute null. Okay. So this is how your full natural outer join will be calculated. Outer join means basically we have to include all the rows present in both these relations, but if a particular value of the common column is not present in one of the relations, then in the columns present in that relation we put the value as null. Okay, so what you have to do, I'll summarize again. Pick each row from a table, then find out if the common column has the same value in the other row. If it has, then substitute the corresponding values in the remaining columns, else put null. Okay, and do it for all the rows present in both the relations. Now what does the question demands? The question asks that which one of the following statements is correct. So R contains A, B, E, F, G but not C and D. So let's see what is A. A is 1, 5 and null. Does R contain 1, 5 and null? No. So this statement is clearly not acceptable. R contains all of A, B, C, D, E, F, G. No, since R does not contain A, so this statement is also not correct. Then the C option is R contains E, F, G. Now what is E, F, G? E is 1, 5, 7. Yes. F is 3, 7 null. Okay. And G is 4 null and 9. Yes. All these three are present here. And the second part of this option is, but R does not contain A and B. Okay, R does not contain 1, 5 null we have seen. And what is B? 1 null and 7. It is also not present. So yes, this option is correct. You can check for the remaining option to reconfirm your answer. R contains E. What is E? 1, 5, 7. Okay, but not F and G. F and G are present here as we noted in the C option. So D option is also incorrect. Now switching to the second question. The question says that consider the relation X with the columns P, Q, R, S, T and U with the following set of functional dependencies. And you are given a set F with the dependencies. The first one is P, R determines S, T, and the second is P, S, U completely or combinedly determines Q and R. Now the question says that which one of the following is the trivial functional dependency in F plus, where F plus is the closure of F, and you are given the options. Now before you proceed and look at the options and start solving, you must know that what does trivial dependency actually mean. Trivial functional dependency says that if the right hand side of a functional dependency is a subset of the left hand side, then we call it a trivial functional dependency. Okay, so if we have a functional dependency, say X determines Y and Y is a subset of X, okay, then X determines Y is trivial. Okay. So let's see the options. In the first option, P, R determines S, T. Here S, T is not a subset of p comma r, so this is not a trivial dependency. You don't even need to check for f plus. If you are clearly able to check from the options that you are given that what is the trivial dependency, and you obtain an option, or you come across an option that is in which the right hand side is a subset of the left hand side, then you can clearly say that yes, this is the correct answer. So let's check here. Right hand side is not a subset of the left hand side, so this is not the correct option. P comma R determines R comma T. Again, R T is not present in the left hand side, so not a trivial dependency. P comma S determines S. Yes, S is present as a part of the left hand side, so this is the correct answer. Even if you need to check D, P comma S comma U determines Q. Q is not present in the left hand side. It is not a subset of the left hand side, hence it is not trivial. So this was a very simple and direct questions, and such questions are very easy to gain marks in your exams. So you need to be very clear about your concepts in such. So starting with the first question, select operation in SQL is equivalent to, and the options are the selection operation in relational algebra, the selection operation in relational algebra except that the select in SQL retains duplicates. The third is the projection operation in relational algebra, and the last option is the projection operation in relational algebra except that the select in SQL retains duplicates. Okay. So when comparing SQL select and project operation of the relational algebra, then what do we actually find? That the select operation in SQL is actually equivalent to the projection operator, the projection operator or the project operator in relational algebra. But there is a significant difference between the two. The difference is that the projection operator of relational algebra does not retain duplicates, and the select operator in SQL retains duplicates. That means, so the duplicates, if they are present in the result and we have used projection operation, then those duplicates or multiple values that have the same actual value, multiple rows that have the same value, all those rows will not be present in the final result. Rather, only a single row representing all those rows would be present. Okay, but the select operator in SQL does not it retains duplicates, and it does not eliminate multiple occurrences. Okay, so if I give you an example, and I have a column, I have a relation named student, and I have 4 columns in them. Or let's make the table easier, and let's maintain 2 columns and multiple rows. So this is roll number and this is name. Okay, so there are 4 roll numbers, 1, 2, 3 and 4, and let's say we have X, Y and Z. Alright, so if I apply select operator here, select name, and this is the student relation from student. Okay, so the select operator will give me a result which is equivalent to name, X, Y and Z. Alright, so these two values or these two rows which have the same value of Y will be retained. So the result will contain a total of 4 rows. But if I use the project operator, the project operator will return the result as, the name of the column would be name, and the rows that would be result would be X, Y and Z. So the project operator would remove one out of them and would simply put a single row corresponding to y. So this is the result of project. Okay, and this is the result of select. So the correct option for this question would be the projection operation in relational algebra, except that select in SQL retains duplicates. So D is the option. Now in this question, I would also like to suggest students that please don't stop at option C and tick mark the correct tick mark or choose this option as the correct option before reading the next options. Generally, students do this in the paper, and to save time, the first option that they find suitable, they put it as the correct answer, they mark it as the correct answer and proceed to the next question. Please read all the options in each of your questions, because as you saw in this question, the C and D options, partially they are same, but actually the correct option is D, because D is more detailed version of this detailed answer of this question, and that is more correct. The C option only states that select operation in SQL is exactly same as the projection operation in relational algebra, but actually it is not true. The difference has to be stated, and it is stated in option D. Now coming to the next question. The next question is, consider the following transaction involving two bank accounts X and Y, and the transaction is read X equal to X minus 50, then write X, then read Y equal to Y plus 50 and write Y. The constraint that the sum of the accounts X and Y should remain constant is that of atomicity, consistency, isolation, or durability. Okay, so if we are given a constraint, and the constraint is that the sum of these two values X and Y should remain constant. So what does it actually means? That before this transaction happens and after this transaction happens, no matter what changes were made by these transaction, the final value of the sum of X and Y should always remain constant, and this consistency should be maintained. That means there is no exception to the rule that the values of X and Y can be changed in a manner which does not make their sum constant. Or what should I say, that consistency is the correct answer here. And why is it so? Because the rule of consistency actually refers to the fact that any database transaction must always change the variables in such a way that is allowed by the database. Okay, the values of X and Y can only be changed in a manner so that this constraint remains valid even after the transaction has been completed. So the correct answer is consistency, and I will write a short definition of consistency for you that I just explained. This rule or this fact refers to the requirement, or it states the requirement that any database transaction must change the variables or must affect the contents of the database only in allowable manner. Only in allowable manner, and retaining all the constraints that were held before the execution of the transaction. Okay, only in allowable manner, also retaining the constraints present before the execution of of the transaction. Okay, so what does it means? It only means that you can change the value of the database variables in a consistent manner, and consistent manner actually means that if there are certain constraints imposed on certain variables and values, you should maintain those constraints no matter what you do within a transaction. So that is the answer of both these questions. Thank you for watching the video. I hope you understood both these questions. If you have any doubts, you can mention in the comment section below. Please subscribe to the channel of Easy Engineering Classes for more such lectures on our preparation series as well as other computer science related subjects. Press the bell icon to get the notifications of our upcoming videos so that you always stay updated and don't miss a video. Thanks for watching. Good luck. Stay tuned.